So I'm going to be your tour guide about the periodic table of elements, and if you were to Google it, you would see all different colors, all different scenarios for it, but you would see the basic structure of the periodic table. It just might be in different colors and things like that. This one is the one from the back of your book, so I just went ahead and took a picture of that one so that you know what's there, and I wanted to explain it to the back of your book. Any periodic table will have a key that kind of explains what each thing is. So, first of all, this part in your book explains to you what each of these things mean. So the C is the chemical symbol for carbon. So you can see all along here, these are the chemical symbols. It'll even tell you what it is, which is super helpful because some of them, like gold, for example, is AU. So unless we take the time to memorize those, we wouldn't necessarily know that. So it's helpful for that. You have the atomic number. That is how many protons are in the nucleus and generally how many electrons are in its shells. Usually those match. And then you have the atomic mass of the item. Almost always double or pretty close to it from the atomic number. Each periodic table is going to somewhere explain what their colors for their table mean. So this part, the background, represents these blue, yellows, and green boxes. If it's a blue box, it's a metal. So all of these elements are metals. If it's a green box, it's a metalloid. Those there that kind of follow some of the rules, but not all of the rules towards being a metal. And then anything yellow is a non-metal. All of these here. By the way, this one here lives right there. So that's what this one explains. So the colors you're seeing in the backgrounds, in the whole box, is telling us whether those are metal, metalloid, or non-metal. The chemical symbol, the color of the letter itself. Notice some of them are red, some of them are blue, just one of them I see as blue, and some of them are green. So that signifies on this particular periodic table whether it's what its state of matter is. So state of matter, if it's a red letters, like carbon is here, like beryllium is here, and magnesium is here, then they are solid. And that would be like at a typical room temperature. So they're telling us at a typical room temperature, what state of matter would these things come in? Because as you know, states of matter can change depending on what we do to the temperature. So these are the state of matter that these items are in at a typical room temperature. So a lot of these are solids, you can see, because they are red. If they're blue, then they are liquid at a room temperature. Here you see mercury at a typical room temperature is in liquid form. And if they are green, they are gas. This is not the backgrounds, this is the letters. So here you are gases at a typical room temperature. Helium, as you know, is a gas. Oxygen, as you know, is a gas. So as you look at a periodic table, any periodic table, look for the key that explains what their colors represent. Another thing to point out is all these groups are sometimes referred to as families, and they are grouped up in these certain ways. A lot of times because of the way the valence electrons on that outer shell, the valence shell, line up. So if we were to look at these, this section here, this family, this group 1, if we were to look at the Bohr model for these, we would see one electron in the valence shell. So there's one valence electron out there, unprotected, right for the pickings. If another element wants it, it has an easy chance of getting it. And if you were to look at these over here in group 17, in this family, if you were to look at their Bohr model, you would see their valence shell has 7. Remember, 8 is what they really, 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 really want in their shells. So this one has 7 electrons in their outer shell. So, just one more would be great, right? These have 1. These have 7. These ones tend to try and steal their 1, which makes these elements very reactive with these, because when those electrons start moving around, that's when you have chemical reactions. Okay. Sometimes if you get in the middle, they kind of just join and share them if there's not that too big of a change between them. But these family with these family are very reactive elements. Really helpful to know if you're about to run an experiment and you're using an element from this family and an element from this family. You're going to know there's going to be some sort of reaction. So, wear goggles and protective stuff and all that. In this family, their valence shell has 8 electrons. So happy, so content. They don't need any more electrons in their valence shell, so they're really not reactive at all. Nothing else is trying to steal their electrons, and nothing, and they don't need any more electrons. So these are the least reactive of all of them. So that's just kind of a quick little overview of the periodic table. And of course, as you go on in your years in science, your instructors will build upon that.